Hi everybody, welcome back another technical demo around the Quarkus application. My name is Daniel O. In this video, I'm going to showcase how to scale your Quarkus application based on memory utilization on OpenShift container platform. We're going to use a horizontal part autoscaler. Okay, let's get started demo. Okay, here's my local environment. We're going to use Maven command line to generate Quarkus application, the latest version 1.11.1, and the project group ID, and here's artifact ID and the version ID, and then we're gonna generate the sample application to RESTful API, and also we're gonna use the OpenShift extension, which allows you to deploy this Quarkus application to OpenShift container platform. Once you execute this Maven command line, the Quarkus project will be generated automatically in your local directory. As you can see, Quarkus-HPA, our new sample application. Once you open Java editor like a VS Code, and then you can find the generate resource file here, the REST endpoint, and then we need to add another method that will generate the dummy data and then store some dummy data file to increase your memory utilization. Okay, here is a new method I just edited. So endpoint the field, and then we're gonna have one parameter, which is index is just count number. So when you call this RESTful API, we're gonna add a new, we're gonna add some dummy data in the memory like a hash map, and then we're gonna call this method maybe 100 times or 50 times, whatever you need, because we need to feed up memory utilization. Just create the character and then put in some 1 megabyte at one time when you call this method. Now let's try to add create a new script, the bash script file to call this RESTful API more easily. So create a new script file, for example, new file, and then the name field dash data dash bash script file, and then here's the bash script file, and then with one parameter, and then just call endpoint. We're going to replace the route URL based once we deploy this application to OpenShift container platform. Okay, just put in the 1-2 second sleep time to increase steadily the data feed up. And here's the application property to define OpenShift extension, but also we can define container resource management request and limits. The limits means the maximum and the request is a minimum. So 256 is a limit, and 128 is the request. Here's the OpenShift cluster and the empty project here, and I just make sure to log in the same project based command line, and try to maybe packaging this application, which allows me to deploy this application to OpenShift container platform with one single command line. So once we run this application command line, and you can find the OpenShift processor will be triggered automatically, try to create image stream and a packaging application as a containerized, and then deploy OpenShift container platform in a row. It takes a few minutes, totally depends on the, what kind of application logic do you have. So build just succeed, and go to the OpenShift console. You can find the Quarkus application just deployed, and then next step, you're gonna copy the route URL into the bash script before we call the endpoint here. So go back to our bash script and then replace the route URL here and the endpoint hello dash field with the parameter. Actually, the one of the beauty of the OpenShift cluster, you can have the Grafana dashboard. So when you go to admin the console and go to Grafana, and there are predefined dashboard here. The one of that is Kubernetes pod dashboard. So we're gonna change the namespace our project, and then we don't need to monitor CPU usage, but we need to monitor memory usage, change the iteration and the time period to update this application. So here is the one pod we just deployed OpenShift, the Quarkus pod, and then go back to OpenShift Web Console and the Developer Console URL and topology view, and then click on View Log, how the Quarkus is running, and then you can see here the Quarkus just running out without any specific error. It looks great. And then go back to the topology view, and then you have a memory utilization from request. This is the condition of how to scale your application based on HPA, horizontal pod autoscaler by OpenShift Container Platform. All right, so let's make a new HPA, go back to OpenShift console and create a new HPA autoscaler, and the minimum is 1, and let's try the maximum 10 pod. In the memory utilization, you can have the request average request utilization, so maybe 60%. So when you go to HPA detail, and then you can find the minimum, maximum, and the current utilization 56% and target and 60%. So which means the recommended size matches the current size without, so there's no auto scaling is triggered yet. So let's try to call endpoint to feed up some kind of data, and then we also annotate route to make the change the network traffic policy around robin, because once you scale up, we need to split the traffic to multiple pods. So as you can see, the new megabyte is just data is feed up, and then it takes a few seconds or a few minutes to change your metric, because the metric data came from C advisor and go to get aggregate to Prometheus, and Prometheus showcase that. So now we gotta change the metric utilization and 66%. So that's why HPA controller was able to update the scale desire replica 2. And then when you go to topology view, you can see that another part it is just running, and can you when you click on the view logs, and you can find another the printout showcase here. So it's already a load balanced two pod from network traffic for end user invocation. When you go back to Grafana dashboard, and you can see here the two pod is up, and then the network traffic is automatically rebalanced based on round robin policy annotation. Okay, we just done 100 megabyte, but still just two pod is scaled up. Let's try to trigger several times to increase memory utilization in two pods, in which increase scale up more pod in this project and namespace. As you can see, some more incoming data is coming from the end user, and then go back to the HPA detail page. You can find that more scale will be show up. So try to invoke another endpoint to feed up more data. Okay, now we have 3 replicas here, and then when you go back to topology view, it's the 3 pods are running well, and when you go to the raise the pod in the logs, and then a new is already load balance automatically and rebalanced your incoming data, and then go back to Grafana view, and the new pod is just come out. There is a little bit delay between OpenShift console and the Grafana, because there needed some time to aggregate your metric data from C advisor to Prometheus and to Grafana. So now 3 pods are running, and you can find that in Grafana UI, and the memory utilization still 69, which more than target utilization 60%, which means HPA will keep auto scaling your pod along with their target utilization 60%. Okay, we have another pod just up, and go back to Grafana UI. You have the 4 pod is running, and then you have the memory utilization. Okay, so today we're gonna learn about how to scaling your Quarkus application based on memory utilization using OpenShift HPA. Thank you for watching. Have a good rest of the day.